Hello and welcome back to another PC build. Today I'm going to be giving you a step-by-step guide to building a PC without a GPU. So chances are if you're watching this video, you're thinking about building your own PC. There is one big problem, however, at the moment, and that is you just can't get your hands on a graphics card, and that's any graphics card, low end or high end. And I know a lot of you have got all your components sitting ready to build and are just waiting for the graphics card before you do. There is, however, an alternative option, and that is to get a CPU with integrated graphics. You can go ahead and build your PC, use it with some limited performance, and then later on when you get your graphics card, unlock the full potential of your PC. So that's what I'm going to be doing and testing today and seeing, is this actually worth doing? So to do that, I've got one of Intel's new Rocket Lake CPUs. It's the i5-11500, which is a 6-core, 12-thread CPU, which should give us some great gaming performance. The reason I've gone for this particular CPU is this is actually the cheapest Rocket Lake CPU that comes with Intel's UHD 750 graphics. And this is the graphics that I'm really keen to test the performance on. So first thing I'm going to do is show you how to put all the parts together. Next thing I'm going to do is test the performance of the integrated graphics. Because of course, just because you can do this doesn't mean you should. Next I'm going to be testing whether you should use the stock cooler that comes with your CPU or whether you should get an aftermarket cooler. And it's not just as simple as your temperatures are going to be lower with the aftermarket cooler. It comes down to the options you're going to get in the BIOS, and I'll show you this later on in the video. If you're using the stock cooler, the power limits on the CPU are going to be lower than if you're using either a tower cooler or water cooler. So does that actually extra cost translate into performance benefits? Again, that's one of the things I'm going to be answering in this video. The final thing I'm going to be doing is dropping a graphics card into the system, rerunning all the benchmarks to give you an idea of the performance you can expect when you actually get your hands on a graphics card. Okay, let's get on with the build. So for the motherboard for today's build, I've gone with MSI's B560M MORTAR Wi-Fi. And I've been really impressed with the B560 motherboards. For a start, you get Gen 4 support for one of your M.2 SSDs and for your graphics card, and you're also able to overclock your RAM. So I think if you're doing a low-end or middle-end gaming PC build, B560 is definitely the way to go rather than Z590. The first thing for us to do is to go ahead and install our CPU. It's going to go in behind this cover. So we just need to push this lever down, bring it out to the side, lift it backwards, and then lift this backwards. Next, I can go ahead and lower the CPU into the socket, taking care to hold it just by the sides and also to make sure that the gold triangle is in the bottom left-hand corner. Then I can go ahead and close the cover over. And then as we close the lever, the black cover will flip off. And then I'm going to put this into the motherboard box. Whenever I remove the CPU, I can put it back on to protect the pins on the socket. This is our stock cooler, and as you can see, it's got thermal paste pre-applied. Next, we can go ahead and line our stock cooler up with the holes on the motherboard. Once we're happy everything is lined up, all we need to do is push down here to secure it. Just checking at the back of the motherboard, we can see the cooler has come through each of the 4 holes and the little black pin in the middle is securing things in place. Next, I'm just going to go ahead and plug the cable coming from our CPU cooler into the CPU fan header. And then I'm going to go ahead and tuck the excess cable out of the way. To install our M.2 SSD, we're going to need to remove this heatsink. It's held on with 2 screws. The drive I'm using for today's build is the T-Force Cardea Zero Z440. This is a Gen 4 M.2 SSD in 1TB capacity. You can of course get yourself a much cheaper SSD by going with a Gen 3 drive and getting less capacity if you don't need the full terabyte. So all we need to do is insert the drive into the socket at a slight angle, and then whenever we flatten it down and put the heatsink back on, the screw holding the heatsink is also going to secure the drive in place. If you're using the motherboard for the first time, on the back of the heatsink you will have some plastic protection to remove. I've used this before, so I've already removed it. We're now ready to go ahead and install the RAM. The kit of RAM I've got has got 2 sticks, so we're going to need to open the clips on the 2nd and 4th slot along from the CPU. The RAM I'm using for today's build is also from TeamGroup. I've got their DarkZ RAM, 16GB and 3200 MHz. So I'm going to go ahead and line the RAM up with the slot. Once we're happy everything's lined up, I'm going to apply some firm pressure to the top. It's going to lock into place and the clips are going to close. Same thing with our 2nd stick of RAM, line it up with a slot and apply some firm pressure. For the case for today's build, I've gone with the Deepcool Matrexx 40. This case offers incredible value for money. For only £40 you're getting a tempered glass panel and 3 included case fans. To remove the tempered glass side panel, we just need to loosen the thumb screws at the back and then we can go ahead and slide the case backwards and lift it away. Same thing with our other side panel, go ahead and loosen the thumb screws, slide things backwards and lift away. At the bottom of the case, attached to all our case cables, we've got an accessory bag which includes our instruction manual and also all the screws we're going to need to secure our motherboard. So we can go ahead and insert our motherboard into the case, making sure to line the I/O shield up with a cutout at the back of the case. Then we can go ahead and secure the motherboard into place using the screws from the accessory bag. We're now ready to plug in the case cables. The first one I'm going to start with is our HD audio cable, which is going to go into this header down the bottom left hand side of the motherboard. So I'm going to go ahead and put it through the cutout, and it needs to be plugged in with the HD audio text on the cable facing up the way. And then we'll just pull the excess cable through to the back. Next we need to plug the case's USB 2.0 cable. It can go into either of these 2 headers here. I'm going to bring it through the cutout. And importantly, it needs to be plugged in with the USB text facing down on the cable. And then again, excess cable pulled through to the back. Next is our USB 3.0 cable. It's going to go into this header here. So I'm going to bring it through the cutout, line things up with the header, push into place, and then pull any excess cable through to the back. Next we need to plug in the cables for our power switch, reset switch and hard drive indicator LED, and they all go into this one header into certain pins. So it's important you pay attention to the diagram in the motherboard manual so you plug these into the right pins. I prefer to start in the bottom row working up, so we're going to start into pins 1 and 2 in the bottom row working from left to right, and that is for hard drive LED positive and negative. So I'm going to go ahead and bring the cable through the cutout. We're going to need to plug it in with the text on the cable facing down the way, and then we'll go ahead and push into place. The next 2 pins in the bottom row are for reset switch negative and then reset switch positive. So I'll bring our reset switch cable through the cutout, and then we're going to need to plug it in with the text facing up the way. And then again pull the excess cable through to the back. Then we've got our power switch, which I'm going to bring through. It's going to go into pins 3 and 4 in the top row from the left hand side, and it's going to get plugged in with the text facing down the way. We're now ready to go ahead and install our power supply. The power supply that I've gone with for today's build is from Corsair. It's their CV550, which is a 550 watt power supply. This power supply offers great value at only £45. It comes with all black cables, which is going to make our build look great. So importantly, our power supply has an intake fan, which we're going to want facing down over this vent at the bottom. So I'm going to insert it with this facing down the way. Then we can go ahead and secure the power supply into place using the screws from the accessory bag. We're now ready to go ahead and plug our power supply cables into the motherboard. We're going to plug our 24-pin connector into here and our 8-pin EPS connector into here. Looking at the top of the motherboard, we've got both an 8-pin and a 4-pin EPS connector, but our power supply only has one 8-pin EPS connector. That's not a problem because our CPU will run just fine with the 8-pin connector. The additional 4-pin connector just provides even more power to the CPU. For example, if you had a power-hungry CPU that you were going to overclock. So we'll go ahead and bring the cable through the cutout at the top of the case, line things up with the socket and push into place, and then we'll pull the excess cable through to the back. Next up, I'm going to bring our 24-pin connector through the cutout, line it up with the motherboard, apply some pressure. It's going to lock and clip into place, and then we'll pull the excess cable through to the back. Coming from each of the case fans, we've got a Molex connector. Our power supply has two Molex connectors. So I'm going to join two of the fans together and then plug these into one of the connectors on our power supply. Then I'm going to go ahead and plug the other fan into the other connector. And then we'll just tuck the excess cables into the bottom of the case. Then we can go ahead and use the included cable ties to help tidy up the cables. Okay, so that's the build complete, and that was definitely one of the easier PCs that I've built. I think the whole process took about 45 minutes. So if you've never built a PC before, this would be a fairly easy guide to follow. So we're now ready to flip the power switch and see if the PC boots. Importantly, I have taken two steps. I've plugged the DisplayPort cable directly into our motherboard because we've got no graphics card to plug it into. And the other thing is I've loaded a Windows 10 bootable USB drive into the back of the PC. If you don't know how to make one of those, I've made a video on it and you'll find a link to that in the description. Okay, so let's flip the power switch. So that's a good sign. We've got lights and fans spinning. So we're just going to have to keep a close eye on our monitor and see what happens. So that's a good sign. The MSI logo has appeared. So the next thing we're hoping to see is the Windows installer screen, if it can find the Windows 10 bootable USB drive in the back of the PC. Okay, that's us through to the Windows installer screen. Next thing to do is get Windows 10 installed, get it set up, and then install any drivers that we're going to need. I'm not going to record these steps because I've done a full step-by-step build guide in the Antec Dark Cube using the same motherboard. So those steps are going to be very similar to that video, and if you don't know how to do them, you'll find a link to that video in the description. And all the steps are time-stamped in that video, so you can go directly to them. There will be just a couple of slight changes from that video, and I'll point these out to you. When you're installing your motherboard drivers, you're going to want to install the graphics driver because we're going to be using the integrated graphics. And obviously you're not going to need to install the NVIDIA drivers I installed in that video because we don't have a graphics card. So I'm going to go ahead and do all those steps and I'll come back to you and show you the BIOS settings. Okay, that's us into the BIOS. There's two settings that I want to adjust. So we click on the memory. We can see our memory is currently running at 2400 megahertz. It can run at 3200 megahertz. And if we see down here, XMP Profile 1 is available at 3200 megahertz. So I'm going to go ahead and enable it. The next thing we need to have a look at is our CPU cooler tuning. So this is what I was talking about at the start of the video with the different power limits depending on the type of cooler that you're using. You can see that the limits here are much lower if you're using the box cooler compared to using either a tower cooler or a water cooler. So we're going to select the box cooler because that's what we have installed, and we're going to click yes. Okay, that's all the settings changed. I'm going to click the X button, click on yes, and then our PC is going to boot back into Windows and we'll test the performance. So starting off with the temperatures, our CPU idled at 41 degrees while under a 10-minute IDA64 stability test with all components in the system being stressed, our CPU reached a maximum temperature of 102 degrees. Looking at the graph, you can see during the initial rise in temperatures there was some significant thermal throttling by as much as 27%. And while the IDA64 stability test was running, you can see our CPU was only running at 3 GHz. Noise levels were also on the high side, with our PC idling at 42 decibels, while under the IDA64 stability test this increased to 50 decibels. It is important to remember that our PC doesn't actually have a GPU in it, and the fans in the GPU are actually one of the loudest components in a PC. So 42 decibels at idle is incredibly loud, and that was largely due to the fans used in the PC. When I ordered the PC, I didn't realise that these were Molex powered fans, so they were always going to run at 100% regardless of what was going on with the PC. So while I was otherwise really impressed with this £40 case, had I known that these were Molex powered fans, I would definitely have stayed away given the noise levels. Also, as well as not doing a great job of keeping our CPU cool, the stock CPU cooler was also incredibly loud, and definitely you could hear it ramping up when we started the test. Moving on to the benchmarks, starting off with Cinebench R23, we got a multi-core score of 8206. Again, during this test, our CPU ran pretty hot, reaching a maximum of 100 degrees C, and again there was significant thermal throttling noted by as much as 29%. Our CPU core clocks were running well below what they could do at only 3.3 to 3.4 GHz. Moving on to Unigine Heaven 4.0 in 1080p with low quality, we got an average frames per second of 42.6. And as you'd expect at that frame rate, the footage wasn't smooth and was quite jumpy in places. Moving on to the gaming benchmarks, and all games were tested at a resolution of 1920 by 1080 at low graphics settings. Starting off with Fortnite, we got an average frames per second of 58, and although the graphics quality did look pretty low, this was playable and felt actually reasonably smooth. I did try increasing the graphics quality to medium, and although everything did look much better, it really wasn't playable at this frame rate. There was a lot of stutter and jerkiness. Moving on to Valorant, where we got a very impressive average frame rate of 121. Again, I did try increasing the graphics quality to medium settings, and this time things were very definitely playable with an average frame rate of 92 and everything remaining buttery smooth. Going on to Shadow of the Tomb Raider, using the game's built-in benchmark, we got an average frame rate of 16 frames per second, and as you can see from the footage, this would be completely unplayable. It was a similar story with Watch Dogs Legion. Again, using the game's built-in benchmark, we got an average frame rate of 11 frames per second, and again, as you can see, this would be completely unplayable. So moving on to test whether you could actually edit videos on the PC using DaVinci Resolve Studio. So I imported a clip from the project. It was a 4K clip in Blackmagic RAW. I did limit the playback resolution to 1080p, but actually scrolling through the clip was reasonably smooth and was very definitely usable. Applying a simple auto color was, however, incredibly slow on the PC. Normally this would happen within round about a second on the PCs I'm normally using. It took round about 20 seconds on this PC. Rendering the 4-minute clip was incredibly slow at 9 minutes and 40 seconds. So summing up the video editing experience, it's definitely usable, but there will be some noticeable limitations. The next thing I wanted to test was the effects of adding a proper CPU cooler, because the stock CPU cooler really did a terrible job in terms of both temperatures and noise. So I went ahead and replaced the stock cooler with a 240mm AIO. It was the brand new Cooler Master ML240 Illusion. And as we were now running a more powerful cooler, I was able to go into the BIOS and increase the power limits to the CPU. So starting off with the temperatures, our CPU now idled at 12 degrees cooler at 29 degrees, while under the 10-minute IDA64 stability test, our CPU was actually 13 degrees cooler at 89 compared to 102 degrees. This wasn't the end of the story. There was no throttling at all observed using the AIO, while when using the stock cooler we had up to 27% throttling. As well with the AIO, we had all cores running at 4.2 GHz during the stress test, while with the stock cooler all cores were running significantly lower at only 3 GHz. Noise levels were also significantly lower with the AIO, down by 2 decibels at idle and 7 decibels under load, although now a significant proportion of that noise is coming from the Molex fans in the case, as we've already mentioned. Moving on to Cinebench R23, and with the AIO we got a whopping 25% improvement in our multi-core score. Not only that, but during the test our CPU reached a maximum temperature of only 65 degrees compared to 100 degrees with the stock cooler. As well with the AIO, no throttling was noted, with all cores running at 4.2 GHz. This was compared to up to 29% of throttling and all cores running at only 3.3 to 3.4 GHz with the stock cooler. Moving on to Fortnite, we got a massive improvement in the average frames per second with the AIO, increasing to 93 from 58, which is a whopping 60% improvement. As well as getting significantly more performance with the AIO, our CPU also ran significantly cooler by 44 degrees, and you did hear me right, 44 degrees, reaching a maximum of 56 degrees with the AIO compared to 100 degrees with the stock cooler. Looking at the other gaming benchmarks, there was no significant difference to the frame rate by using an AIO compared to the stock cooler, and also in our DaVinci Resolve render time there was no significant difference as well. So I think by summing these results up, by using the stock cooler, you're going to have a CPU which runs significantly hotter, significantly noisier, and you're leaving a lot of the performance that you've paid for behind. You don't need to go all out like I did with an AIO, and I think picking up a simple tar cooler for around about £30 is definitely going to be worth it, because I think having your CPU throttling all the time and running at 100 degrees isn't going to be great for its long-term life. So the next thing I did was I went ahead and installed an RTX 3060 Ti in the system, because I was really keen to test the performance of this CPU paired with a GPU. Starting off with Unity in Heaven, again sticking with 1080p but increasing the quality to high from low. The frames per second increased dramatically all the way up to 276. Moving on to the gaming benchmarks, and all games were tested at a resolution of 3440 by 1440 and using high graphics settings. So in Fortnite we got an average frames per second of 192, in Valorant it was up to 298, in Shadow of the Tomb Raider we got 88 frames per second, while in Watch Dogs Legion we got an average frame rate of 86. Looking at our DaVinci Resolve render time, this came down from 9 minutes and 40 seconds to 1 minute and 19 seconds, which was over 7 times quicker. So summing things up, I've been pleasantly surprised by the performance of the integrated graphics in Intel's 11500. And for simple tasks such as browsing the web, using PowerPoint and Word, there's absolutely no difference than with a PC with a graphics card. Certainly no difference that I could notice anyway. I was also very pleased to be able to play some games such as Fortnite and Valorant at very playable frame rates, albeit at low settings. But I think it goes without saying, you're not going to be able to play some of the more powerful AAA games using this integrated graphics. So I think if you are somebody who's thinking of building a gaming PC but just can't get your hands on a graphics card, this is definitely an option to consider. I think the other big advantage of this is, should something happen to your graphics card in the future, you're going to have the integrated graphics to fall back on. I remember building my son his first gaming PC, and just after a month his graphics card failed and we had to return it for RMA. That whole process took over a month, and that was a month where he didn't have a computer that he could use. Had we have got a CPU with integrated graphics, we could have fallen back on that, and then at least he could have used his computer for his schoolwork and for some light gaming. So hopefully you found the video useful. If you have, please remember to give it a thumbs up. And if you're not currently subscribed to the channel, please hit the subscribe button as well. Thanks for watching.